We are going to be going through the tracking refinement process that we used for the Pathways project. This takes the onset jetset tracking data, scan, and camera calibration, and goes through a import process into SynthEyes to refine it to a high-quality sub-pixel level tracked shot that we can have direct 3D integration with elements that actually contact the live action photography, in particular this front end area of the rock. So let's go through that. So we're going to start off by running a script, and this script is automatically generated by AutoShot, and this script imports the combination of the individual frames required for the shot, as well as the onset tracking data, as well as the onset calibration. And as you can see, this is the shot playing back, and you can see that we have scan data overlaying the shot imagery. You can see it's a relatively rough scan, only accurate within a few centimeters, but that turns out to be good enough to make this process work. It's closely referenced to the onset rock wall, but it's not exactly precise. If we zoomed in really close, we can see that it's shifting around a little bit. So let's go ahead and work through the process to correct that. First, we need to actually create a few trackers on the tracking markers in the background. Get our magic wand, go to the beginning of the shot, and let's place a few trackers. All right, that should do it. And let's pick all of them and then track them forward in the shot. Great. And we'll just lock all those trackers. Since we want to connect things to the rock foreground, we also need to place some trackers on the foreground rock. We're going to want to pick areas that are a dark or a white spot surrounded by a different color that are relatively close to the front surface of the rock, so they're not all the way buried in one of the cracks. We want to do that because if we show the mesh, then the mesh itself is actually fairly low precision. It sees a kind of one block there. So we'll pick spots that are relatively close to the front. So let's pick a couple points here that will work well for tracking. There's another dark spot. There's a good dark spot here. Some more points here. We're just picking spots where it's a relatively easy to track point. Okay, all right, let's select all those. And again, let's track forward for the shot. Okay, great. I'll lock those. So now we have both the background and foreground points tracked so that we can get the correct parallax for the shot. Here's the scan of the onset mesh data that has the correct position and orientation. If we just hit the solver right now, we might get a solve, but it won't be in the correct position and orientation or the scale. All that information will get thrown away. And we want to preserve all the information we had from the set. So we want to keep that information. The way we're going to do this is we're going to pick several of our trackers, and we're going to do track, drop onto mesh. And what that has done is it's projected from our current camera viewpoint, which remember is largely correct within a couple of centimeters from the onset jetset data, where we projected through the tracked points that we found in the scene onto where it intersects with the mesh. And likewise, we're going to do the same thing with the background. We're going to select a few of these tracker points, and we're going to do track, drop onto mesh. And now that has set those 3D points as survey points. So if we look at a quad view, and we go, we can see that we've forced those 2D points to match onto these 3D points in the scene by projecting them onto the mesh. You can see the kind of the red spots here. So now we can see where our camera is, and then when we go to our solver, you can see we're going to click solve, and now the shot is just solved. We can see that the tracked points have stayed there, the camera's moved slightly, and the overall shot is doing reasonable. It's about 0.823 pixels of error. And we want to make that a little bit better. And it looks like the larger error is coming in toward the end. So as we scroll back and forth, we're looking at the radar, which is the size of the circle, which correlates with the amount of error in the track. And this one is looking like a little bit of an ugly track that isn't working that well. So I'm going to delete that. We're going to go to our refinement process and click refine. And now we're down to a much more reasonable amount of error. And we can check to make sure our mesh is still in the place where we expect it to be. Yep, so the mesh is still correlated with the geometry, but now it's stuck at a subpixel level, which is exactly what we want. Okay, so from here, what we can do is pick out a few points. I'm going to go and hide our overall mesh. So I'm going to go to Quad Camera and Hierarchy, and I'm going to hide the scan mesh for a second, so that when we go to our camera, we're going to pick out a few of the different points. And as we click on the different points, we can see how much error each one of those points has. And what we want to do is tell the post-production team what are the best points to hook stuff to. And so this is one of the lowest error areas. So we're going to duplicate mesh onto trackers. So we're actually going to drop what we call a chisel onto that. And so that's just a 3D point that says this is a good tracking point. And this one also is quite good. So this is 0.779. So I'm going to script drop onto mesh. That's just a good way of telling people where the best tracking points are to reference. This one has a little bit more error, and this one has a little bit more error. So we're gonna stay out of those. All right. So there's our scene, and right now we can go to our solver, and we've got a little over half a pixel of error. We can do a couple things to try to improve that. Our script sets it to a known focal length, and that's what we measured on set. But we can also try using that as an estimate, seeing if the solver can get slightly lower error. Okay, so we have a little bit lower error here. And then we can also start calculating distortion. So we can tell it to calculate distortion. We'll just use the classic model and enable quadratic distortion. And we can tell it to solve. And again, we got a slightly lower error, not a huge amount, because there's just not that much distortion in this lens, but it's always good to calculate that for the next part of the process. Once we've calculated distortion, we actually want to undistort the imagery before we send it on to a tool like Blender, because the traditional 3D tools or the AI tools don't actually know what distortion is. And so we need to give them undistorted imagery to work with. So we're going to go to our lens workflow, and we're going to calculate our undistortion. And what this is doing is using the distortion value that we calculated to undistort the imagery. And you can see now that we've grown a little black border around the image. That means that we increase the image size slightly to handle the slight stretching of the image that happens when we undistort. And let's go ahead and do another solve. And we've got a good track, so things are moving correctly in 3D space. And we are aligned with our original imagery. So if we go up onto a quad, and you can see where our tracked points are here on the front, and we can see where they are in the back. And so we can actually go forward and start to export. So let's go ahead and export a Blender scene. And here's our tracked scene in Blender. Of course, we can't see the footage yet, so let's go ahead and hide our scan, and we'll come out to the scene. So our footage is a long way away, which is why we can't see it. So let's go ahead and pick our camera and set our cursor to that camera and set this object's origin to the camera, the 3D cursor, and turn off the lock. And let's scale it down so it's closer to our camera. Flip through the camera again and set our rendering to materials. Okay, so now we can actually see the scene rendered in Blender with the tracking data. And so we can zoom in and see how well the chisels are lining up to that particular spot that we had them tracked to. And you can see the chisels are aligned up quite accurately. And we have in our Blender scene, we'll actually bring up our mesh again. So you can see our chisels are nicely located close to the reference scan imagery, and behind them is the imagery of the actual live action. So things are lining up. And importantly, one of the things we're doing here is as we zoom in here, you're going to see that the imagery has a little extension here, very similar to what we saw in SynthEyes. And this is because when we exported from SynthEyes, it actually generated a image plane that we can put the shot onto, and it incorporates the undistortion into the image plane. So this means that we can actually be working with our original distorted plates going into Blender, but it's undistorting them via geometry inside Blender, and that way everything lines up. So that's a very elegant way to work. So now we have something that can be correctly imported into the rest of the scene and aligned with the imagery, and we can add in rocks.